You have come across this voltage selector on some of your appliances. We use it to choose the right voltage depending on our country's grid. So normally we find it with 115 volts or 230 volts. We have the AC coming in, the 4 diodes for the full bridge rectifier, our voltage selector switch, the 2 smoothing capacitors in series, the voltage waveform on the AC input, positive half cycles and the negative half cycles. When the switch is open, like this, it's set at 230 volts and the bridge is rectifying both half waves. This is what is on the output of the bridge rectifier. The capacitors hold the voltage close to the peak of the wave as DC. To calculate the voltage at the peak, we multiply the AC times the square root of 2, which is 230 times square root of 2, which gives us 325 volts. 325 is shared between these two capacitors since they're in series. So the voltage on one capacitor will be the half of this, which is 160 volts. When switch is open, you get 160 volts. Switch open, 160 volts. When you close the switch, the voltage is set at 115 volts. So at that point, the bridge rectifier also acts like a voltage doubler. It rectifies one half cycle to charge this capacitor using this diode in this direction. The other half cycle is rectified by this diode to charge the upper capacitor in this direction. When the switch is closed, the waveform on this capacitor lower capacitor after smoothing, of course, you get the peak DC, which is 115 times the square root of 2. The switch is closed on this capacitor, you get 162 volts, and the lower capacitor also 162 volts. So regardless of your country's grid, the voltage on each of those capacitors is maintained, and on the total output you get plus or minus around 325 volts.